Hello everyone, welcome to the channel once again. I hope you are doing good. I'm continuing with the data structure series. Now in this video, we'll learn about another data structure. Now suppose you have been given a task to implement this kind of shopping portal where you have to list down various items for the shopping. Which data would you use in this kind of scenario? You can see there are a lot many items and all items have few information, and if you click on any of the item, it will fetch all the informations about that particular item. So you have to have such data structure which is very fast in searching, which is very fast in fetching data based on something. So let's study the data structure which if I would have been given the opportunity to implement this site, I would have used that data structure for fetching these data, fetching this information. So let's study data structure which is hash table. Now what is hash table? Now hash table is another kind of data structure where data is stored in a key and a value pair. Now there could be key and there would be a value. Now if you'll add any item to that data structure, it will be added in a key value pair only. Not that you add key and then you can later on you can add value. No, you have to add in a pair key and the value. Now the value is not necessary to be of a particular data type. Like here you can see in values I have inserted one integer, one is string, and one character also. And the key also need not to be integer. It can be a string also, it can be character also, it can be any object also. So where the key and the value pairs you insert in a sequence, and there is no restriction on saving of data of a particular data type. Like in arrays you have this indexes which can be key, but that indexes will always be an integer. It cannot be string. Indexes are always integer. But here you can have the key and the value. Key could be a string also, key can be any other type of data type. Now this hash table is useful for fetching data or inserting data. It almost fetches in a constant time. Now here the word almost I'm using. I'm not using every time because in worst case it could be linear, but in average time or in most of the time it is a constant time because it fetches data based on key and it does not iterate through all the elements. It directly goes and pick the data from that key, and it is particularly useful if you have a large data set. We have seen arrays in detail in previous videos where you were filtering data based on the index and you directly go to the data. Here also you directly fetch the data based on the key, so data is fetched in a constant time. Now one more thing to be remembered, that hash table does not save data in a very predictable order. Like in arrays you save data in a particular order. Here in hash table you do not have any predictable order in which you save data. Now what is this hash table? Now here if you want to understand the hash table, you have to understand this hash function. What is this hash function? Now when you enter a key, that key goes through a hash function and it outputs a value which is an integer value, and that integer serves as a index or a key for a value. Now suppose I have this key value as a test data. Now suppose I have a key as a test data. Now when I'll implement the hash function could be anything. Like it can be any function which converts, which just take input and convert and throws output. In my hash function I am just adding the ASCII values of all the characters. Now I have this test data, I can add the ASCII value of 116, and then in TE I'll add the ASCII value of E, and then I'll add ASCII value of S and T, and similar. I'll add all these values and it will come with a number, an integer number. That value can be hash value. That output can be used for the hashing. Now you can say that test data could also be written as data test, and their hash function would also be same. Like it will also throw if we'll pass data test in place of test data, it will also throw the same summation as test data. Yes, so in that case a collision will happen. Then in hash function the concept of collision resolution comes, which we can cover in the next slides, but it is a complex part and I am just simplifying it for your understanding. It's not as simple as adding the ASCII values of all the characters. No, all the compilers, like if you go with Java and you can see the JDK library, or in Python, everybody has implemented their own hash functions. Like in Python you have a dictionary, in Java you have the hash table. So at this point in time nobody goes and write dictionary or hash function, they just use it. I'm just explaining what is going behind the scene. Now once you input a value and hash function converts it and throws an output, this is not reversible. can again throw the input through the hash function, and you can not get the input value. So that is the thing, it is not reversible. So somebody could ask me, then it is similar to encryption and decryption. I am passing any value and a function is encrypting it and throwing me the encrypted value. No, the difference is in encryption and decryption, you can encrypt the value and then you can decrypt that value also, but in hash function it does not happen. This is non-reversible. So a function will take input and will throw output which would not be reversible. Now I was talking about the conflict resolution in previous slides. So there are multiple methods through which conflict resolution is done. It is done using chaining, it is done using open address and load factor, and in open address also there are linear probing, quadratic probing, double hashing. These are the things. I'm not going in detail of it, but you should know the conceptual terms at this point in time, because that are very advanced topics and I don't want you people to be bogged down with it with so many information. So first understand the hash, and probably if I'll make video on advanced topics of data structure, then I would be covering all this. So conflict resolution means if you pass key value and it goes to this value 2, similarly if key 3 passes through a hash function, it can also go to value 2 for saving the data, but here already data is present, so there would be conflict, and that conflict is resolved through these concepts: chaining, open addressing and load factors, linear probing, quadratic probing. In linear probing, like once they divide and then linearly they increase, like if I go and check for this value 2, and if I find the value is already present at value 2, then I'll go to the next level, and here I'll check if the value is there or not. If it is not there, then I'll insert. If it is there, then I'll go to the next value for checking. This is linear probing. Similar to quadratic probing, you will quadratically, like you will square the value and then you will check. Double hashing, you will pass that function by double, and this is the most efficient way how conflict resolution is done. So this is how it is done. I'm not going in detail of it. Few examples where you can use hash table, like if you want to use the country and the capitals, flash, card game. These are the few examples where hash tables are very useful. Let's go to the lab and implement hash table. So this is my JDoodle. I have this Python ready. Now I'm using Python and we'll see how we can use the hash table, which is in Python called dictionary. So I'll initialize one empty variable, empty dictionary, and then in items I can add items, and I can add suppose key1 I can add 1, and then in items key2 I can add, now you have key, key2 you can add 2. Similarly I will add few more items, so you can add 3 and 4, 3 and 4. So if I'll print this, and I'll go and run this, you see this is printing key1, key2, key3, 4. This is the hash table, which is in Python called dictionary, and this is an empty dictionary which I have implemented. Now how I can iterate on this element? I can iterate through for key value in items dot items, and then I can print key and then value, I can print value. Now if I go and run, you can see the key1, key2 is printed sequentially. Now I can write here, suppose RAM vector, and now also if you run, you see the key could be anything. It's not necessary that key is, you see vector here, key here also you can see, so key could be anything. And here you can also save any variable, like suppose that you want to save any string value to that also you can save. So it is not very specific to you see this 2 is also saved. Now key to value is 2, key to value is 2. You can save any object here, you can save any data type, you can save. It's not necessary that you have the integer. So it's very handy, it's very useful where you are dealing with fetching, like in shopping sites. So hope you understand it. Conflict resolution and everything I have not covered, because that would be complex, and if you watch in a sequence you may be bogged down by the details. So maybe I'll make a next video in which I'll in detail explain this conflict resolution, how we do conflict resolution. So that's all for now. Thank you so much. If you're liking the videos, please do subscribe to the channel. It means a lot to me and it motivates me a lot to make more videos. Channel is in its infant stage, so your support is required for the growth of the channel. So please do like, share and subscribe the channel. Thank you so much.